and thank you, Professor Santamarina, for that insightful and informative talk. I'm pretty sure the audience had a great time learning about the various physicochemical processes influencing all these phenomena. We have a few interesting questions coming up in our way, and without further delay, I shall start picking up the questions for you. Uh, One of our attendee would actually like to know, given the geographic mismatch between the energy resources and consumption centers, can you please share your thoughts on how geoengineering can help bridge this gap?
Mm, that is a very good point. One of the issues that when you analyze the energy situation worldwide, one of the issues that emerges is the profound inequality, uh, and that happens both within each country and across countries in the world, which inequality creates a whole series of dynamics, and reading geopolitics is a way to get a grasp of the importance of that. But in addition to inequality on energy availability, one of the other issues is the geographic mismatch, as you said, very well said. For example, the high consumption in North America and Europe compared to where the energy resources are. For example, Russia and Iran are blessed with energy resources that Europe depends on that critically. And so this creates a very complex situation worldwide, and you can fill in the dots just by reading the news every day. Now, the one energy resource that is very democratic is the sun. And by the way, the sun is shining particularly strongly in areas where, within the tropical band, in areas where there is also high population densities, etc. So the possibilities related to the sun are exceptional. And because it is everywhere, then we don't depend on a grid so much as we may depend on others, except that to balance the loads may still be good. The geographic mismatch, that is a very good question. The geographic mismatch in energy resources and energy demand is something to keep an eye. One more thought, and I address here the case of the US. The US, to, to the surprise of many, is actually one of the largest fossil fuel producers, not only consumers, fossil fuel producers in the world. And shale gas was a very lucky, between quotes, opportunity for the US in the last 20, 25 years, totally unprecedented.
Thank you so much for the response. Moving to the next question. In one of your slides, you talked about methane hydrates. One of the questions that came around is, given the high methane content in the hydrates, how can we balance their energy potential with the climate risk?
Yes, and that is one of the concerns with methane hydrates, that if there is sea level rise and warming, and now we are going to move the phase boundary, and areas where methane hydrate is currently stable, it may become unstable. Uh, I think that there are some interesting analysis on that. Probably the question didn't point to that, but I'll come back to the question. There are some interesting analyses. The rate at which these processes are going to take place are slower than the rate at which the methane hydrate mass can reassemble itself. And so I wouldn't be too concerned with that. But still, sudden dissociations of methane hydrates can cause probably dramatic effects. And there are possible examples. For example, the Bermuda Triangle and big bursts that may have taken place around the Gulf of Mexico are probably associated to that. So that dissociation of methane hydrate would aggravate clearly climate change, but could also create instabilities on the seafloor that would be quite detrimental.
Thank you so much for the response. Moving to the next question. Among the considered renewable retrieval processes of hydrogen fuel, which one would you believe has the lowest carbon footprint?
Hmm. Um, well, if we create methane, for example, by splitting the water molecule, we need energy, and that would be the solar energy or the wind energy in the best of all cases, right? So we use a renewable energy to produce hydrogen. So then hydrogen actually is a way, it becomes a carrier. It's a nice way to transport that energy from one location to the other. So it's not an energy resource in itself, it is a carrier. So somewhere we need to produce it. So the only possibility here is to use the hydrogen that nature may be generating by itself. Of all the other ones, we need to make the analysis very carefully because there is a whole series of systems around that will be required, and all those systems around that are required are CO2 producers to generate them, to operate them. So you need to be very honest with yourselves and do a total life cycle analysis, including the decommissioning of facilities, a total life cycle analysis to convince yourself of what is the actual carbon footprint in using hydrogen.
Sure, that sounds good. In the interest of time, we have so many questions coming in, but I can take one final question. Professor Santamarina, if you could comment some of the techniques that could be used to monitor fracture sealing in the real-time process.
Yes, that is a very good question. And if we are going to be storing some of this CO2 or hydrogen, then we will have to do some monitoring for leaks. And that monitoring could be the gas dissolution in the fluids, or could be geophysical techniques, like, for example, changes in the P wave velocity when gas forms and displaces water, so the P wave velocity changes dramatically. If it is methane, you can even do it with satellite imaging. So as soon as we do storage of any of these gases, there will have to be a monitoring component, and we are going to do the same thing post-treatment. We will have to monitor as well the effectiveness of the process.
Thank you so much. I guess we are closing in our Q&A session. So before wrapping up, Professor Santamarina, if you have any closing remarks for our audience today on how they can contribute to this exciting field of research.
Mm. Well, first of all, I realized, number one, that I rushed the presentation. Two, that I didn't answer all the questions probably in the spirit of the question. And three, that there are many questions pending. So I invite you all, please reach out to me, and then you'll find my contact information quite readily. And I'll try to give you better answers. But I think that it is critical that we join efforts, folks. We are I am very optimistic. I'm not uh, pessimistic about the future, but I have to say that the next few decades, let's say 2050, 2050 is coming very fast, and it will affect the young people that are here today at the prime of their careers. We need to do something. We really need to do something. We need to join efforts. Uh, and this is a world-size problem. We need to solve it together.
Thank you, Professor Santamarina. And